Okay, so you're going to label your note 7.6 factoring ax squared plus bx plus c, which that title might seem like a little bit familiar from yesterday. So, like I said, today's notes build off of yesterday's notes. So up at the top, I'm going to talk through these bullet points. You don't have to write both of them down. I would just prefer that you wrote the second one down because it's really important to kind of remember what that part says. So as you guys are writing it, I'll read through it. It says factoring ax squared plus bx plus c. So far, you factored polynomials in the form ax squared plus bx plus c, where a equals 1. So if we look back a little bit at the notes from yesterday, I think that actually these aren't really going to be filled in a whole lot because we're on the other, we did those all on the other slide because we're all together as one class. But basically, all of the problems that we did yesterday, even though you can't see the work, when we were factoring them, all of our x squareds had coefficients of 1. So this was a 1, 1, 1, 1. And so that made there be a lot of consistency in the way that we were factoring. We're going to use the same exact methods to factor today, but now we're going to factor polynomials that don't have don't have a equals 1 or have the coefficient of x squared be 1. So if you look at the second bullet point, it says to factor polynomials in the form ax squared plus bx plus c, where a is not equal to 1. First, look for the GCF of the terms of the polynomial and then factor further if possible. So you guys just need to write down this second bullet point. And the most important thing from that second bullet point is that we should always look for the GCF first. So from here on out, whenever you have any sort of factoring problem, the number one thing that I want you to always look for is the GCF. Because when you pull out the GCF first, it just makes the problem a lot easier to manage. And for today, we're still just factoring trinomials. So even if we do factor out GCF, we will most likely be able to factor them further. And since we're factoring trinomials, we can still use the X method. So I'm going to redraw that template that we talked about yesterday, just so we have it to reference. So you draw a big X. A times C goes on top, B goes on bottom. And we're looking for numbers that multiply to A times C but add up to B. Those numbers will go on the left and right side. And then we need to remember to write it over A. So this is one thing that changes about today, and this is one of the questions that I got from the morning class, was why weren't we writing fractions over 1 like we were yesterday? Well, we weren't just writing fractions over 1 yesterday, we were writing them over our A value, and it just so happened that our A value was 1 yesterday. Today it'll be a different number. And then just remember that the A, B, and C, they come from standard form. So these A's come from the coefficient of x squared. The B comes from the coefficient of x. And then the C comes from the constant. So I'll give you a chance to just finish writing down the second bullet point and then redrawing that template. And then we're going to start with number 1 together. So example 1, it says factoring out the GCF for the greatest common factor. So it says factor the polynomial 5x squared plus 15x plus 10. So whenever you're factoring, regardless of what your expression looks like, the first thing you always want to check for is greatest common factor. And that's just basically like a term, a monomial. It could be a number or a variable or the combination of both that divides evenly into each term in your polynomial. So basically I want to see, is there a number or monomial that divides evenly into 5x squared, 15x, and 10? So because 5, 15, and 10 are all divisible by 5, I can factor out a 5. I can't factor out any variables because that 10 doesn't have like an x to the first power or anything like that. So that x would not be a part of my GCF. but I can factor out 5. So when we factor it out, we can use kind of like the distributive method to figure out what we're left with, or you can think of it in terms of dividing. I'll kind of show you examples of both. For this one, we'll just stick with the distributive method like we talked about when we were just factoring GCF. So to figure out what I'm left with, I can think 5 times what will get me back to 5x squared. It'd be 5 times x squared. And 5 times what would get me back to 15x. That'd be 3x. And then 5 times what would get me back to 10? It'd be 2. So I have 5 times x squared plus 3x plus 2. I factored out the GCF, but I'm not done there. So right here where it says then factor further if possible, that's where you have to kind of explore other options on how we can factor just the part inside the parentheses more. So the x squared plus 3x plus 2. So since that's a trinomial, we would use the x method to factor it. So remember when we use the x method, we want to identify what a, b, and c are. And as you get comfortable, you may not need to write it, but at least write it for these ones. A is the coefficient of x squared, so that's 1. B is 3, the coefficient of x. And c is the constant, the number that doesn't have the variable, so that's 2. And then I can draw my big X. And in my X, A times C goes on top. So that's 1 times 2. So 2 goes on top. B goes on bottom, which is 3. And now I'm looking for numbers that multiply to 2, but add up to 3. So factors of 2, that would just be 2, or 1 and 2. And 1 and 2 adds up to 3, so we're good. We can pick those numbers. If they didn't, then it just would mean that it's not factorable. But they do, so those are our 2 numbers that we put on the left and right side. And then we need to remember to write it over our a value, which is 1. So over 1, that number in the denominator becomes our coefficient of x. And then we need to write our factors from the bottom up. So this like 1 over 1x, if we go from the bottom up, that becomes x plus 1. And then that other one, 2 over 1x, if we go from the bottom up, that becomes x plus 2. But one thing that you have to be really careful of when you factor out GCF is you have to remember not to forget about it. So this 5 can't just disappear. It has to stay in your final answer, or else we've changed the total value of the expression. So the 5 stays out in front, and then our final answer is 5 times x plus 1 times x plus 2. And then with these ones, you can still check by like foiling and stuff. It's a little bit different now because we have that 5 out in front. So I would recommend foiling first and then distributing the 5 in after. So it's pretty much just like doing things completely in reverse order. So if I want to check it, I'm going to foil first. So I'm just going to leave the 5 out in front. And then when I foil x times x, that's x squared. X times 2, that's 2x. 1 times x, that's 1x. And 1 times 2, that's 2. Before I distribute the 5 in, I want to combine like terms. So 5 times x squared, 2x and x together is 3x plus 2. And then from there, I can go ahead and distribute the 5 in. So 5 times x squared, 5x squared, 5 times 3x, that's 15x. And then 5 times 2, that's 10. And that's what we originally had, 5x plus 15x plus 10. So our check worked, and we know we did it correctly. But this 5 times x plus 1 times x plus 2, that would be your actual final answer. Anything below that is just checking your final answer. So for the next 2 problems, these are for you to practice on your own. So I'm going to give you a few minutes to begin those. Both of those are just like the problem we just did together, where you want to look for greatest common factor first, then you'll have a trinomial. So after you pull out greatest common factor, you can use the X method to factor it further. I'm going to leave like the screen zoomed out like this a little bit. So at the top of the page, remember there's this like kind of template that you can use in order to use the X method. So it's there if you need it. But I'll give you a few minutes to work through those and then we'll go through those together. I'm going to start going through these. If you didn't quite finish yet, that's okay. We'll just go through them together. So for A, 4x squared plus 32x plus 60. So the first thing that we're supposed to check is for a common factor that we can pull out. So off the top of my head, I know that I can divide 32 by 4. So I know for sure that I could factor out a 4 from those two as my greatest common factor, but I'm not sure if, say, 60 is divisible by 4. I'm not sure if that would work. You can always use a calculator. So I can check like 60 divided by 4. If I do that, I get 15. So that means that 4 is a factor of 60. If you divide 60 by 4, you get 15. So 4 must be the greatest common factor that I can pull out. So I'm going to pull it out in front. Remember that factoring something out is the same thing as basically dividing it out, but you kind of just leave it in front of it. So if I think 4x squared divided by 4, that would leave me with x squared. 32x divided by 4, that would leave me with 8x. And then 60 divided by 4, that would leave me with 15. So you can always use the distributive method where you like try to think what would I need to multiply it to get back to what I originally had, or you can think of dividing. It's totally up to you and what kind of clicks more for you. So now I have 4 times x squared plus 8x plus 15. So I've factored out GCF, and now I need to try to factor this x squared plus 8x plus 15 further. Since it's a trinomial, we'll use the x method. So on the top is a times c, which our coefficient of x squared is 1, c is 15. So A times C is going to be 1 times 15, which is 15. And then B goes on bottom, which was 8. So 8 goes on bottom. And then I need numbers that multiply to 15 but add up to 8. So for factors of 15, it could be 1 and 15, or it could be 3 and 5. So since 3 and 5 add up to 8, we can use those. So 3, 5, and then we need to remember to write it over our A value, which was 1. So over 1, over 1. And then remember that the number in the denominator is your coefficient of x. So I have 3 over 1x and 5 over 1x, so we can create our factors from those. Remember that that 4 has to stay a part of your final answer, so the 4 stays out in front. This 3 over 1x, that becomes x plus 3. And this 5 over 1x, that becomes x plus 5. So 4 times x plus 3 times x plus 5. And then for B, 8x squared minus 56x plus 48. So same thing, you want to check to see if there's a common factor that you can pull out. So I can check to see if my greatest common factor would be 8. A good starting point for like checking greatest common factor is like the smallest number of the three, if that makes sense. So like between 8, 56, and 48, I could check to see if they're all divisible by 8. And then if I'm not, I might have to pick a smaller number as my greatest common factor. So I could do 56 divided by 8, that's 7, so I know that that's a factor. I can do 48 divided by 8, that's 6, so I know that that's a factor also. So that means that I can factor out an 8. I can't factor out a variable because not all three terms have that x to any power. But when I factor out the 8, I can pretty much divide it out. So I can think 8x squared divided by 8, that leaves me with x squared. Negative 56 divided by 8, that leaves me with negative 7x. And 48 divided by 8, that leaves me with 6. And then I pulled out my greatest common factor, and now I need to try to factor this x squared minus 7x plus 6 further. So since it's a trinomial, we'll use the x method. So a times c on top, which is 1 times 6, so 6 on top. B on bottom, which is negative 7. And then I need numbers that multiply to 6 but add up to negative 7. So here's where it's a little bit tricky, where if you have if you have a positive product, like this is a positive 6, then my factors can either both be positive or both be negative. And if they have to add up to a negative number, like negative 7, then they both must be negative, because a positive plus a positive is never going to equal a negative number. So I know that both my factors will be negative. I can figure out my factors of 6. So it would be 1 and 6 or 2 and 3. But since we decided we're both going to make them both negative, it could be negative 1 and negative 6 or negative 2 and negative 3, because both of those combinations are both going to give us a product of positive 6. So the one that adds up to negative 7 is negative 1 and negative 6. So those are our two numbers. We need to remember to write it over our a value, which for this problem was 1. So over 1 over 1. The number in the denominator is my coefficient of x. So I'm ready to write my factors. The 8 stays out in front. And then this negative 1 over x, that's x minus 1. And then this negative 6 over x, or 1x, that's x minus 6. So 8 times x minus 1 times x minus 6. So the next set of problems is now dealing with when we have like coefficients of x squared that are not 1 and they don't end up changing to 1 after we factor out the GCF. So if we look back at the last few problems we did, like, yeah, all of my coefficients of x squared, they ended up not, or they weren't 1 to start with, but then they ended up being 1 after we factored out the GCF. So it wasn't a whole lot different than yesterday's problems once we pulled that GCF out. But now we'll have problems that do have a different number. So it's the same method, you just have kind of one extra added layer to worry about. So for example 2, factoring x squared plus bx plus c when a times c is positive. So this is just one scenario or one type of problem. So for a, it's 4x squared plus 13x plus 3. So I'll give you guys a chance to write it down and then we'll begin it together. So remember, the first thing that you're always supposed to check for when you factor is greatest common factor. So when I'm looking for greatest common factor, I'm thinking in my head, is there a number that I can divide 4, 13, and 3 by, other than 1? So a common number that I can divide them all by other than 1. And there's not. So that means that there's no common factor, there's no greatest common factor that I can pull out. So if there's not one, it might be still factorable, but we just jump straight to the x method with our 4x squared plus 13x plus 3. So we can draw our big X. A times C is going to go on top, B is going to go on bottom. So A is 4, C is 3. So A times C is going to be 12. And then B is 13. So 13 goes on bottom. So we need numbers to multiply to 12 and add up to 13. So we'll think of factors of 12. It could be 1 and 12, 2 and 6, or 3 and 4. So since I add up to 13, 1 and 12 would be our combination. So 1 and 12. And then here's where things get a little bit different. So up until now, every single time that we've like gotten our numbers, we've said over 1, over 1. But it wasn't that we were just putting them over 1, we were putting them over our a value, which happened to be 1 up until this point. But now our a value is 4. So we're not going to write them over 1, we're going to write them over 4. So our a value can change, it's allowed to change. So it just means our denominator is going to end up changing. The next thing you have to remember is if you end up with a fraction that you can reduce, you need to. So what I mean by that is this 12 over 4 can be reduced because both 12 and 4 are divisible by 4. So in order to reduce it, I'm going to take both of them and divide them by the same number, 4. And that's going to make the fraction have smaller numbers but the same exact value. So 12 divided by 4, that becomes 3. And 4 divided by 4, that becomes 1. And then 1/4 can't be reduced. So these end up being our final like simplified fractions, and we write our factors based on those. So remember 4x, 1x in the denominator, and then we go from the bottom up. So from the 1 over 4x, that becomes the factor 4x plus 1. And from the 3 over 1x, that becomes the factor x plus 3. So 4x plus 1 times x plus 3. And as far as checking your answer, nothing changes, so you can still FOIL it to check. I haven't been doing the check on all the problems just for time reasons, but remember, especially like on a quiz or a test, I would always check it just to be safe. So 4x times x is 4x squared. 4x times 3 is 12x. 1 times x, that's x. And 1 times 3, that's 3. And then from there, we have to combine like terms, which are the 12x and the x. So 4x squared, 12x plus x becomes 13x plus 3, which was our original problem, so we're good. And then for b, 3x squared minus 7x plus 2. So we want to check for greatest common factor first, meaning is there a number other than 1 that I can divide into 3, 7, and 2? And there's not, because 1 is the only common factor of those three numbers. So there's nothing I can factor out, so I can just go straight to the x method. So a times c on top, a is 3, c is 2. So 3 times 2 would be 6. And then b on bottom, which is negative 7. So we need numbers that multiply to 6 but add up to negative 7. So for factors of 6, it'd be 1 and 6 and 2 and 3. But remember, when you have a positive product, like positive 6, but we want our factors to add up to a negative number, we need to make them, both of our factors, negative, because they would add up to, or sorry, a negative times a negative would multiply to a positive, but adding two negatives together, you would still have a negative sum. So -1 and -6 work, because -1 times -6 would be +6, but if we add them together, we would get -7. So -1, -6, that's what goes on our left side. And then have to remember that we're writing it over our a value. So in this problem, our a value is 3. So this is going to be over 3 over 3. And then if you can reduce it, you need to. So this like -6 over 3, because both 6 and or -6 and 3 are divisible by 3, that means that we can reduce it. So we're going to reduce it by dividing each one by 3 to give us smaller numbers but the same value. So -6 divided by 3 is -2 over 3 divided by 3 is 1. And then the 1 over 3, or the -1 over 3 over here, can't be reduced. So those end up being our final simplified fractions, so we can create our factors based off of those. Remember, the x goes in the denominator. So the -1 over 3x, that becomes 3x minus 1. And then -2 over 1x, that becomes x minus 2. So 3x minus 1 times x minus 2. So these two problems down below, like your turn, A and B, those are for you guys to practice on your own. So I'll give you a few minutes to start working through those, and then we'll go through those together. Okay, so for A, 2x squared minus 7x plus 5. So first we're supposed to check for greatest common factor. So is there a number that divides evenly to 2, 7, and 5? Other than 1, there's not a number that would divide evenly into all three of those. So that means we can't factor out a GCF, but we can just jump to the X method right away. So A times C on top, which for this one is 2 times 5, so 10. B on bottom, which B is negative 7. So now we need numbers that multiply to 10 but add up to negative 7. Remember, if they're multiplying to a positive number but adding up to a negative number, they're both going to be negative. So our factors of 10 could be 1 and 10 or 2 and 5. And if we make the 2 and the 5 negative, then they'll multiply to positive 10 but add up to negative 7. So negative 2 and negative 5 are our numbers. And then we need to remember to write them over our A value, which for this problem, our A value is 2. So over 2, over 2, and then reduce it if you can. The negative 2 over 2 can be reduced because they're both divisible by 2. So if I divide each one by 2, the negative 2 becomes a negative 1 on top, and then the 2 becomes a 1 on bottom, just dividing them each by 2. And then I think I forgot to write that 2 there. But the negative 5 over 2, that can't be reduced because they're not both divisible by the same number other than 1. So now we're ready to write our factors. So this negative 1 over x, that becomes the factor x minus 1 because we go from the bottom up. And then this negative 5 over 2x, that becomes the factor 2x minus 5. So x minus 1 times 2x minus 5. And then for b, 3x squared minus 14x plus 8. So is there a greatest common factor that I can pull out? I'm checking to see if 3, 14, and 8 could be divisible by the same number other than 1. And they're not, so there's no GCF there. So I can go straight to the X method. So A times C be 3 times 8 on top, so 24. B on bottom, so negative 14. And I need numbers that multiply to 24 but add up to 14. So if they're multiplying to a positive number and adding up to a negative number, they're both going to be negative. Now I can figure out my factors of 24. It could be 1 and 24. It could be 2 and 12. It could be 3 and 8, or 4 and 6. And if they're both going to be negative, if I make the 2 and the 12 negative, then those will add up to negative 14. So negative 2 and negative 12 are my numbers. I have to remember to write them over my A value, which is 3. So over 3, and then reduce it if you can. So the negative 2 over 3, that can't be reduced, but the negative 12 over 3 can. If I divide them both by 3, so negative 12 divided by 3 becomes negative 4. 3 divided by 3 becomes 1. So now my fractions are simplified and I'm ready to write my factors. So the first one, negative 2 over 3x becomes 3x minus 2. And negative 4 over 1x, that becomes x minus 4. So 3x minus 2 times x minus 4. Okay, I'm going to leave this up for a second longer, but that's the end of the notes. So if you're ready and you're waiting, you can start on Delta Math.